Hey everyone, I'm Gabriel, and for this video we're going to build a small AI project using the Transformers library / API provided by HuggingFace. And as the name of the project suggests, we're going to build a basic pipeline that takes an image as an input, generates a certain story from this image, and afterwards transforms this story into an audio file. So personally, I'm going to use Colab for the development, but feel free to use other tools of your liking. I'm going to use it because of its ease of use and because of its reproducibility. So I'm going to basically provide the ipynb file so you can try it for yourself. One thing to keep in mind also is that I assume you have some background knowledge, at least some basic background knowledge regarding NLPs and the idea behind transformers and how they work, even though I'm going to explain everything. So if you're not that familiar with the concepts, nevertheless, Hugging Face has some great material explaining the main NLP details. And there are also some great resources on YouTube like StatQuest from with Josh Starmer that provide a very rich background, a theoretical background on machine learning and deep learning in general. So without further ado, let's get going. So image to audio story. Let's build a pipeline that takes an image as an input, create a story based on its content, and then generates an audio file based on this text. So personally, I got this image of two men fighting, so that's basically the image I chose, but feel free to get any image of your liking. So yeah, let's get going. First things first, install the necessary libraries. So one thing to keep in mind is that all you need is the Transformers library, the Streamlit, and the local funnel are actually libraries that I'm gonna use afterwards. So they are not that related to the project, but the thing is I created a user interface for some user that just wants the result. So that's why I'm gonna use those two libraries. But if you don't care about it, it's okay. It's just import the Transformers one. So we're also going to use matplotlib.image to print our image and to work with it. So feel free to choose any other tool you're liking, like build.image or something like that. But that's the one I chose. So yeah, first we import the necessary libraries. Uh, Here's the image that we're working on. So you need to have it in the same environment as your file. And to kick things off, we need an image to work with. So yeah, the thing is I provided the code, the cells without code, and the main idea is that we're going to code as we are going through our main ideas. So yeah, we have already imported the libraries. So we have to take our path, which is going to be enemies.jpg, and our image is going to be img.unread, and our image path, image path. Okay, then we're gonna show this image. Make sure to, actually this is T, make sure to also turn off the axis since we want the image to appear as clean as possible. And by the end of it, plt.show. I think that should do it. So let's just wait a little for the code to run. Yeah, everything seems to be working fine, and here you have it. This is our image, the image that we want to create a story based on the context of its image, and then we want the models to create a story, and then we want to convert the story into an audio file. So just like that, our image is ready to be used, and we actually need to segment our development. And why am I saying that? Well, the thing is, when we are doing this cross-tasking project, we are going to use different models because models are task specific. So we have a task that converts image to text. We have another model for text generation based on previous text that was provided. And we also have another model, last model, that basically converts the text to speech, which is basically the final process of our project. So yeah, just like that, our image is already ready to be used. And the next step is to extract the context of the image and convert it into text, as I said here. So image to text. So for it, we are going to basically define a function image to text, which basically takes the image path, which we already have, as we've seen before. Now, one thing to keep in mind, I'm gonna open the HuggingFace platform here for you. Yeah, we have our models here, and these are all models in the hub that we can use. Some provide an API that we can directly get the inference API and run it on your code, and it will run on the hub, so we don't need to actually import the models or the tokenizers, but some don't. So there are basically three ways of getting the models to run. One is to import the models, import the tokenizers, and manipulate them into fitting the tokenized input into the models, which is a more low-level approach. There's a middle-level approach, which are basically going to use. As I said here, there's a tip, which is basically the model which we are going to use, but you can search for the ones of your liking. So I'm going to show you here. We have this model, and when we click in using transformers, this is what we're going to use. We're going to use the pipeline uh, function because it basically has both the tokenizer and the model in an abstract manner. It does everything for us. So that's what we're going to use, pipeline. So yeah, we're just gonna rename this to another thing. We're just gonna rename it to image to text because we're gonna have another functions along the way, and it's very much useful to be specific, right? So our text is going to be our image to text is gonna take our image path, which we are already passing through the function, and I mean there are a few hyperparameters or manipulations that you can perform in your pipeline. One thing I like to do is actually create a maximum number of tokens, and actually each model has its own nuances. So you have to be careful. You have to look into the documentation of its main page, how it's used, if it has any information here. So it's always good to check how the community talks about it, how it's used, and so on. So there's a small thing that I want to talk about, but let's just return, and then we want the text generated from our image. So image text, and let's pass our image path. So when we run this code, it's basically going to import the model and the tokenizer and the format of a pipeline, which basically does all in one. So I already previously downloaded this pipeline of this model, specifically this image to text image model. And if you're gonna run it for the first time, it might actually take, I don't know, 1 minute or two, because it has to download this pipeline. But you don't have to change anything in the code. You just need to run it for yourself. But what it's doing right now, it's basically generating the text from our image path. If we wanted to get in a faster way, we could just use the deploy and inference API. And what it does is that it basically does not need to download, nor the pipeline, neither the tokenizer, the model, provide an alpha model, for example. It will run in the hub, and you just have to provide the input that you want. But anyways, we already have our text, so let's print our text, and this is what we have. We have the generated text, which is they are two men resting in a dirt field with a fence in the background, which is basically pretty accurate to our image. So that's already a good step. But we don't actually want this format because the way it returns a list of a dictionary in which the key is the generated text and the value is what we want. So this is what I said before. We want to actually manipulate it. So we want the first element, and we want the element that corresponds to the generated text. So here's what we're going to do. Turn text equals image to text, pass the image path. But now we are not gonna get this format. We're just gonna get the raw text, the string itself. So yeah, let's see if it's okay. And as I said, it's gonna basically take a while because it's not doing the inference in the cloud, in the hub itself. It's doing the inference here. So depending on the machine, it's basically gonna take less or more time. and I'm not exactly using the GPU or CPU. I'm actually using the default CPU on Google Colab. So yeah, this is a problem. But yeah, now we have our text here, which is there are two men wrestling in another field with a fence in the background. So this is our string. So the first part is okay. Now that we have our text, the we're going to use the pipeline from transformers and opportunity model by Salesforce. Yeah, so yeah, we use the Salesforce. Now that we have our text, we're going to take this text and use another model to basically expand it into a full-fledged narrative. That's what we have here. So let's do it. So for the next two models, I'm actually going to take the fastest and yeah, actually the fastest approach, which is basically, as I said before, use the Hub API. And how am I going to do it? Well, that's a good question. Basically, it's pretty easy. You just have to get the model which you want to. So my next model is actually this big science bloom. If you wanted to, actually search for a model yourself, you just have to go through models and actually get the task, make classification, and segmentation. I know that this one that I'm looking for is a text generation one because I've already used it before, and it has an inference API, which means I can take it and use it in my code without actually having to import it. I basically just send a request and get a response from the hub itself. So we have this API URL and the headers. What happens here is that you need an authorization. So if you don't have a HuggingFace account, create one. It's free. And to get basically this token here, which I'm gonna use for my account, you go to your account, settings, um, access tokens, and generate a new one. I'm using this one, but generate a new one for yourself. And this one is the token that you're gonna use to have access to this API. So getting back to our model, science, yeah, we're gonna basically copy this, all of this, yeah, sure, we're gonna do some manipulations, but okay. So we have our request, so we don't actually need to import it again, so I'm gonna delete it. Since we have quite a number of queries, you have this query, and we are going to have in the future another query for the third model regarding the audio file. We're gonna pass this to the inside. Okay, seems to be fine. The response is going to be the request.post. This is basically default, and return the response.json, which basically tells that we're going to get the response from the hub based on the input that we send to them. Now we are going to, not this output, define our text to story function. So basically gets text. So our output is going to be this text to story, and yeah, as you can see here, our output needs to have a certain format so it can run the query. It has to have this inputs and the text that we're gonna pass. So what we're gonna do here is basically this. Yes, the output is going to be text to story query, and our input is going to be, well, I'm gonna delete this, but just a showcase for example. Let's see what happens when I do this, and we need to return the output. Okay, output is gonna to be, yeah, that's okay. We didn't actually define the function. I actually deleted the function, didn't I? Yeah, I deleted the function. So yeah, this is the format that we're going to. Okay, seems to be fine. I'm just gonna change the name, and yeah. So the last thing we want to do is basically let this be in the right format. Turn the output and call the function itself. So story output is going to be text to story, of our text that we already have. So let's see how it's working. It already ran, so as you can see, it's much faster than the last one. And let's see what we have here. So our text was, there are two men resting in a dirt field with a fence in the background. In our generated story was the generated text. In our story, which I provided here just to give, I didn't want to initiate the story with they are two men wrestling. So I kind of gave it an initial phrase, an initial part to make sense of the story and to turn it into a more readable case. So in our story, there are two men wrestling in another field with a fence in the background. That was the text. And a woman standing by the fence watching them. The woman is the wife, yeah. So from now on, you can see that we already have a much more broad context. I mean, it created a story. There's no woman in the picture, but based on the data that it was trained on and the inferences that it made, it supposedly added a woman into the story. So one thing to keep in mind is that, again, we don't want the output to be in this format. So we have to output, just as we did before, is going to return the 0 and the generated text. So the first element and the generated text from this first element. So yeah, it's going to be the output. And there you have it. Basically have in the format that we want. But as you can see, the woman is the wife of one of the men. What if we actually wanted, a bigger story, a more complex one? The thing is, when you actually implement your model by the inference API, you don't actually have that much power, that much freedom to manipulate the hyperparameters and whatever you want to be specific. But there's actually a way in which you can bypass this and get your way around it, which is basically get the output from your model and use this output as an input to the same model, which is basically going to take the text, feed it to the model. It's going to generate a story, then get the story, feed it to the model again. So it has a lot of more context to work on, and it has to give you information about the story. And this is actually what we're going to do here. So this is the base case which we're going to use, and then we're going to add complexity in our case, which is basically what you want. So feel free to change the complexity of the story in in the manner you like, the manner you prefer. But what I'm gonna do here is I'm gonna take a complexity parameter, which is gonna have the default value of 1. So complexity here also we're gonna be 1 for our case, and for I and range of our complexity, we're going to perform this loop basically. So our output, we just have to copy this. So we don't have this in our story anymore because we are not going to if we did have this in our story, we'd basically append in our story n number of times per se, like the number of complexity units that we have in our model. So we just want to feed to it our output itself, and let's not forget this one. Okay, seems to be fine. And now our model should have a higher complexity based on what we want. So I think that's okay. Let's run it and see. So now we have complexity of 1, so it should have added 1 complexity to our model. So there are two men wrestling, blah blah blah. The woman is the wife of one of them, the man, and the other man is her lover. The two men are fighting over her. The woman is torn. So yeah, as you can see, we actually added another layer of complexity. I mean, it was kind of not the most correct way based on large language models or the NLP itself that was provided. But yeah, there are these kinds of things that you can do to your code. That's what makes it much easier to work with. So yeah, we now have our text. Let me just see if everything's good. Yeah, seems to be okay. So let's check the generated story, and this is our story. And last but not least, we need to convert our story into an audio file. So this means that you can now hear the story come to life based on the image that you provided. So our function, which is gonna be named story to audio, will be our audio performer. It takes the generated story and uses yet another Hugging Face model to transform into an audio file. So just as we did before, let's get to this ESPNet. Just as I said before, also you can just go to models and search for the model audio mode of your use, of your liking. But the one I'm gonna use is the ESPNet. So it also has an inference API which we can use. So let's just copy it. Also, again, be sure to change this to your own key, to make it work and to actually work on your projects. So let's copy this and put it in your code. We don't need the requests. Let's just change this as we did before. Put the API in the header both and the query. Change the query name into something more related to what we're gonna do. So we did before was text to story. No, actually, yeah, text to story query. So this is story to audio query. Story. Okay, seems to be fine. And we're going to call this story to audio query. And our output, actually, let's define the function just as we did before. Define a function which is gonna basically be this one. Change a little, we're gonna tweak around. So this is story to audio. Is gonna take the story as an input. So we're not gonna take text anymore. And yeah, for this problem, we actually don't want to store the file into a variable. We want to create a file, in the same repository, on the same directory, to so we actually can have a file that we can listen and see if it corresponds to our story. So I'm gonna delete this actually here. We don't need it, and we're just gonna call story to audio query, passing the story, and we actually don't need the response. No, yeah, we need the response, but because the response is necessary, so we can receive what they return, but we don't need to return it. What we need to is create a file which is gonna be an audio dot, I don't know, mp3 or FLAC, any other. I mean, I believe it has a support for some kinds of files, different files. So mp3, we're gonna write it and as file, and then we're gonna write on this file the response content. I believe that's correct. And last but not least, so after story query, story to audio. So yeah, we are going to call our function story to audio story. Okay, seems to be fine, I guess. Sure. Yeah. Oh yeah, this takes as story input, story output. So seems to be okay. Let's just ident this and this. So let's run it and see if it works. And yes, apparently it worked. I don't know why it's saying that it's not indented, but yeah, these are problems that current Colab. And now we have an audio MP3 file. So yeah, let's pray and check that this MP3 file corresponds to a story that was generated from our image. We downloaded it, and I'm gonna put it to
In
listen.
our story, there are two men wrestling in a dirt field with a fence in the background and a woman standing by the fence watching them. The woman is the wife of one of the men and the other man is her lover. The two men are fighting over her. The woman is torn.
Well, as you can see, it seems to work. I mean, we're actually feeding it an image and it's generating an audio file. So if we just ran all of this at once, we wrapped it in a single file, it should just request for the image and provide a story audio file based on this image. And well, if you remember in the beginning of the video, what I did was I installed the Streamlit in the local tunnel, and what I'm doing is actually basically creating a simple user interface and serving the basically serving everything that's here wrapped to a web server. So that's basically what this app.py app.py file is all about. I actually converted it, but as you can see, I passed everything that I passed in the Colab to it. Text to story query, image to text, but in different names. You can choose one of your liking. But yeah, so I already took the liberty to run this, but you basically need to run all these commands, which I'm going to provide, and just access the URL that is provided by the end of the code. And voila, we have this turn image into audio app. So we just basically need to get an image like this enemies one. And what's fun about it is that, you know, first of all, it's quite easy to use. You just upload the image, but in the code, I've also added the complexity to, run in a persistent manner. So we already have uploaded the image, and what is going on? It's doing all of the tasks. It's getting the complexity of 1, which is the default, then generating the text, which describes the image, then generating the story from this text, and by the end of it, afterwards, it's generating the audio file, which we are going to be able to listen inside the browser. So let's just wait, and yeah, that's it. Let's run the audio file.
In our story, there are two men wrestling in a dirt field with a fence in the background and a woman standing by the fence watching them. The woman is the wife of one of the men and the other man is her lover. The two men are fighting over her. The woman is
Okay.
torn.
Yeah, and as I said before, you can change the image to anyone of your liking. So like as the model is generating all of the pipeline regarding the for complexity level, I actually want to encourage you to try it on your own images, and actually to also manipulate the code and tweak around a little to see if you have any issues or have any new ideas. And this basically just proves how easy it is to actually took around on Hugging Face and to implement your own models and ideas and tasks. There are a lot of cool tasks in Hugging Face provided by the community. So yeah, but this one I believe it's a pretty cool one, and it does require some background knowledge. You need to know what you're doing here, why you're requesting from the API inference. Try newer models, like try models that I didn't check before. Here there's spaces of tasks provided by the community, so there's audio to file, music to gyroscope, open object detection that you can see for yourselves and try to figure out what's going on, and be more active in the community. So let's see if it generated. So it's generating still, but yeah, I think I've kind of given the main idea behind it. It was a really cool project to work on. Quite a simple project, but it's done what it's need to do. So that's basically it. And since this is running in a loop, you could also uh, choose another image to kind of see what is the story behind each of them. But yeah, this is mostly it. I hope you guys enjoyed the video, and well, see you next time.